Assalamualaikum warahmatullahi wabarakatuh and very good morning to everyone.
Waalaikumsalam.
How are you? Sihat ke?
Sihat, Alhamdulillah tu sihat-sihat.
Alhamdulillah, Alhamdulillah. Ada yang tengah buat LI ke? Ada yang tengah buat LI? Sebab semalam ada yang ni. Ah, Siapa tu? Siapa tu? Okey, okey, okey. Semalam siapa WhatsApp saya? Ada dia seorang. Seorang je lah. Sabir, where are you right now, Sabir?
Yes, doctor. I'm in the campus.
Okay, good. So we will communicate in Malay, eh? Is that okay?
Uh,
In
the
in Bahasa Malaysia.
the whole course, like all the classes in Malay.
Can you speak Bahasa Malaysia?
No, doctor.
You already 3 years in Malaysia.
3 years, but all the courses are in English, right?
So right now is the time do you need to learn. Okay?
Inshallah, inshallah, doctor.
Alright, okay. So everyone. So right now we have already 27% in my list. There are 33 students. Okay, never mind. We just start. Alright, okay. I think some of you might know me or might maybe I don't know whether you know me or not previously. I think I found some familiar name. Okay, so basically I am Dr. Amir Putra bin Mak Saad. You can call me Dr. Amir. Uh, apa lagi nak cakap What else you want to know? Later on lah nanti saya share. So okay, for today's class only 1 hour bagi tahu awal-awal. For today's class only 1 hour, and then I will give a few tasks later on today's class, and then because we have another class on Thursday. Okay, so basically on Thursday we will try to have 1 or 2 hours. Okay, so basically our design class normally you have uh, uh, 2 hours lecture. So on Monday macam sekarang what you have right now. So 2 hours lecture, basically lecture or discussion lah lecture. And then we have another 3 hours. Kalau you tengok you punya credit adalah SEMM 4533. So 3 back there basically 3 credits. Tapi because of kita dalam design kita perlukan sometimes masa yang lebih. We need to have a few more times lah to be discussed. Okay, so before kita cerita berkenaan dengan lecture, I will need to explain to you about our course information. Saya tahu mungkin ramai rasa, alah doktor, why do you want to share with us about this course information? We just can read it. I know, but I need to tell you. Alright. Okay, can you see my slide? Okay, thank you. Alright, okay, again, disclaimer at the beginning of the class. Alright, so with me, I think siapa yang pernah kelas dengan saya mungkin dia tahulah kot. Mungkin ada ramai, saya pun tak familiar nama ni. Mungkin ada ramai tak pernah kelas dengan saya. Alright, so I would like to emphasize here. Okay, my style, I'm a totally an open person lah. Open, which means that once you give commitment, for example, you give 100% commitment to me, I will give you 120% to you my commitment. So that is my style. Okay, mana-mana sudah kenal saya, kalau you give your commitment, you don't do nothing issues to me, and then I will give you exactly extra more commitment to you. Okay, I really apa nak cakap I really appreciate, I really acknowledge your commitment. Alright. So with that, because you are in apa and you need another 2 semester to become an engineer, that is really important to us to make this class system design very interactive, very lively session, so that it's not boring. Okay, so this is a design class. Lecture maybe ada a bit. A lot of more kita akan banyak discussion. So I need your interaction with me. Okay. Alright, so let's proceed with the confirmation first. Okay, so confirmation you see here code is SEMM 4533, which means that you are you registered to UTM at the year of 2018, I think September at that time. So this is your cohort lah. Okay, 2018, 2019. Okay, so every person yang daftar register at the particular academic session supposed to be your code is SEMM. You must check your code because if you are from different cohort, your code must be you register as SKMM probably. So right now we are using SEMM. The course sama je, cuma the code is different. It is very important for you to to be careful lah because untuk graduate. And then the prerequisite for this subject is SEMM 3523, which is component design. Okay. I know some of you maybe I heard previously a lot of students score component design, which is good lah. Okay, so because you need to use all the knowledge that you have been practiced previously in this system design. Okay, alright. So let's read about the course synopsis. This course is designed for students to gain a detailed topical exposure. Okay, detailed topical exposure to design methodologies. Okay, I believe, saya sangat-sangat yakin because a lot of you dah ambil introduction to design, but long time ago. Okay, long time ago lah, long time ago. Long time ago. First year, that is the main problem kita dekat UTM. Kalau you tengok mana-mana universiti, contohnya saya ambil UKM ke, UKM or UM, dia akan ada dekat-dekat. Contohnya semester 5 you ambil, semester 6 you ambil I2D, Introduction to Design, and then the following semester you will need to take the system design, or they call that IDP2, Integrated Design Project number 2. Alright, so but sama we are in UTM, we design differently lah. Hopefully in a few coming years kita akan buat dekat-dekat lah, but the project must be the complex enough lah to suit the complex engineering nowadays. Alright, so to design methodologies and principles specific to the practice of mechanical design, emphasizes on developing efficient and effective. This is the common question I would like to ask. What is the difference between efficient and effective? Okay, somebody boleh voice out je, tak ada masalah. Dengan saya sempoi-sempoi. Alright. What is different between efficient and effective? The difference is the process and the product. The process and the product. Okay, good try. Apa nak panggil ni? Chung Tek Ke panggil Siti je?
Siti.
Siti Aduh, tak komersial lah. Alright. Okay. Anyone? Yang lain? Okay, Azuki dah petik nama lah. Cepat.
Okay, efektif ni macam kita buat satu plan. Benda tu dia macam ni entahlah.
Kau dah pergi LI ni. Patutnya dah okey ni.
To be honest, I don't have any idea about the different.
Okay, nama siapa nak petik?
I think I would like to call Mirza.
Okay, Mirza.
If just in general, I think efficiency is the amount of effort for, let's say, your system to complete the amount of effort the system needs to do for a targeted objective.
Okay.
But for like effectiveness, has it accomplished the final objective?
Yeah, correct. Oh, jawapan skema Okay, skema jawapan. Saya pun dah confused. Dulu ada satu term what we call as to define effective and efficient. Do right things or things do right things, or do right things.
Right to do.
Right things to do. Do right things to do. Okay, so basically in that way, in that sense macam Mirza sebut tadi, that is the correct one lah. So we basically effective is that we achieve our main target. Okay, efficient our system betul lah, sistem ke proses ke apa ni derive accordingly Okay, so that is about the efficient and effective design technique. So we will utilize both. Okay, kalau masa you maybe you have learned from the introduction to design class, maybe it's very straightforward. Okay, because at that time maybe you don't have so much idea. So right now you are already in basically it's open up a few applications that you have been looking at. Okay, so this is the time kita nak tengok macam mana improvement, there is improvement or not in terms of are you able to come up with the different idea, the creative idea. So kita tengok nantilah. Okay, so as well as project oriented skill from both technical and non-technical consideration. At the end of this course, students should be able to identify and apply appropriate methodology, which is you will use design process as a guideline. And then on the analysis part, kalau you masih ingat introduction to design, you will not emphasize on the analysis part. You only need to do after you construct your final sketch, you develop your 3D model using whatever CAD models that you have, SolidWorks ke, AutoCAD ke, and then you develop 3D model, I think, and then you go to the competition, I think. So just do a simple mock-up, okay? But somehow different between the system design. You will need to utilize the analysis part. Okay, that's why we will you will need to be use technical and non-technical punya consideration lah. Okay, to perform design tasks, recognize the fundamental principles of mechanical design such as free body diagram, dynamics if you have a motion, what else? Solid mechanics, fluid mechanics if you involve with the fluid, thermodynamics if your system have a thermal system, and then if you have static tu dah sebut tadi, free body diagram, basic tu. Okay, so kena guna balik lah basically all those things. Kalau for example you involve in a water ataupun dekat in water or dekat air, so kena ada stability punya calculation. If you need a vibration, you can involve that one, that particular part. Maybe your system you nak guna concept of control system, mechatronic and everything, so you need to utilize that part. So it depend on the complexity of the project lah. Okay, and formulate and apply general problem solving strategy. Okay, problem solving strategy. I need your strategy. I need to know. So what meant by strategy? Okay, apa?
The procedure.
Procedure.
The plan to solve an
Okay.
issue.
Lagi? Siapa lagi nak jawab? What is strategy? Thank you, Zuki.
Alright.
Siapa lagi nak jawab? What is strategy?
The way we approach to the solution.
The way we approach to the solutions.
I mean, yeah, for the problem, the solution to the problem.
Solution of the problem. Okay. Lagi? Sharwin dulu. Sharwin. Dulu you kelas dengan saya ke? Saya ingat nama je. Sharwin?
Ya, betul saya.
Okay.
ITD.
Okay, strategi. What can you define by strategi? Apa strategi? Apa itu strategi?
Strategi dia macam maybe idea macam mana kita nak selesaikan satu-satu masalah.
Okay, idea. Alright. So once you discuss with strategy, basically you deal with an option. Okay. So kalau you ada only one way, cakap this is our strategy, only one way, that is not called strategy. Okay. So you will have a few options, a few ways. So you need to select the best one. This is our main strategy. Our first priority, this is the plan. Plan A, plan B, plan C. That is what we call as strategy. Okay. Same goes to once you become a leader in management. Later on, hopefully lah, after 5 years you have been working as an engineer, technical engineer, and then you will live up your career through by joining the corporate level. Okay, so once you joining the corporate level, now your soft skills, whatever you have learned in university, such as you become a leader or what else, so those things will help you a lot. To be frank with you, to become a technical for a long time is not, I think to me, it's not really satisfied. Okay, so basically once you jump into the corporate level, then that is good for you lah. The salary is much huge compared to the technical part. Okay, so you need to deal with the strategy, a lot of strategy. Okay, so potential problems you need to be looking at. So after this kita akan tengok, saya rasa masa dekat component design, I still remember once I taught the component design previously, we will deal about the how we looking at on the potential problem. We identify through the force flow, for example. So you need to know where is the force flow, where is the starting of the force being exerted to the structure, and where it will end. Okay, then you will know where is the localization on and so on lah. So that is what we call as the potential problem. So that is really important. At the end of this course, students should be able to identify and apply industry standards in design communication. For example, you will produce the technical drawing that easily can be understand by manufacturer or fabricator. Okay, so this is the outcomes that you will get. Okay, so ada 8 outcome. Kalau if I can read, okay, analyze background study, PDS, product design specification, investigate design problem into multiple solution, basically concept generation, analyze possible solution. You need to come up with the final concept, synthesize into final design using appropriate engineering tools, which is the what we call the final design scoring. Okay, generate the detailed documentation of final design. Okay, construct the test working. Generate the detailed documentation. This is the design embodiment, which is from sketching you will convert into body using the whatever CAD model that you have. Construct and test working model. This is a bit different compared to I2D. This is if in introduction to design, basically what we teach you up to what level you are able to prove the concept only, which means whatever you sketch, whatever is your idea to solve the problem, your concept generation, basically that is the solution to the problem lah. Okay, so the way you solve the problem is through sketching. So how we would like to know, are you able to demonstrate the proof of the concept? You will prove it through the 3D model, for example, or you will a simple mock-up, which is you know how to solve the problem based on the concept generation, and you construct the mock-up or the virtual prototyping, for example. Okay, but somehow different in system design, you will need to prove of function. Whatever concept they will conduct, you need to prove the function it will be working and solve the current issues. Okay, related to your project lah. Okay, conduct oral and written presentation. This is required. You will have your own mark on presentation and as well as the reports. Okay, and assume responsibility as team leader and adopt team working to solve design problem. That is why we have a lot of time basically. Kalau you buat lambat-lambat, maka you akan siap lambat-lambat. Especially we have get a comment from MPP. Okay, MPP have raised the comment from the student. They said that they don't want any project submission after or during or after study week, which means on week 16, I believe. Okay, so based on that, okay, our TNCA Deputy Vice Chancellor Academic have highlighted, so every single project which don't involve with any final exam need to be submitted by or before study week. So that is the rule right now. So you need to ask your MPP lah. I don't know because they raise the issue.
Mantap.
Okay, because previously we tolerate a lot. Okay, kita bagi masa yang banyak for you guys to complete even sampai habis final exam pun kita allow lagi untuk submit. Because sebelum ni kita ada competition dan sebagainya. Because of that, and then kita set the date lah. Okay, alright. So that is about the outcome. Okay. If you see here, this class is don't have any final exam. It's totally 100% project. Okay, student will work in group of 4 or 5. Okay. So this is the week schedule. Supposed to be today, this week. We will look at an overview of course information, an overview of system design, And on our next coming Thursday, we're looking on the mini project assignment and discussion. Okay, later on phase 1, we have 5 phase. Phase 2, phase 3, phase 4. Before mid-semester break, you need to submit your first report lah. Your first report up to phase 3. Okay, so your first report up to phase 3. So in week 7, at the end of week 7, before you go to the mid-semester break with happily don't have any project and assignment, you need to submit before week 7. Okay, so up till phase 3. And then our focus right now up to virtual prototyping only. Hopefully if after week 8, for example, and the government allow you to go to the lab, and then we will adjust our project. So, okay, so that you could produce a product of your prototype, the real prototype, the physical prototype by your own group. Okay, so this is the mark. I will show to you the detail of the mark so that you know the detail of the mark later. Okay, so this is the book that we will use. The main reference here, you can download any sources. So my suggestion is that if you could use, I will most of my lecture will refer to this lecture book, to this textbook. Okay, currently I think they have the 5th edition, I think. Okay, alright, I think that's all about the course information. Ada soalan tak so far?
So system design much related to engineering management, right?
Engineering management. Engineering management is a part of the system design.
Oh,
Okay. Nanti kita akan ada, we will have I think 1 hour ke half an hour session kot on the project management from the industrial lecturer lah, lecturer yang mengajar subjek industri. They will talk to you on how on the engineering management a bit kot, on the project planning. And then we will have another session with the materials punya lecturer on the material selection. Okay, alright, so that one is later on lah. I will let you know. Okay, so right now I would like to show to you about the mapping markah. Mapping markah. Mapping markah. Okay, this is the mapping design process, or mapping the marks for all of you lah. Okay, like to enlarge, right? Okay, so if you still just now in CI course information, we will have 5 phase, including the generic skills. Okay, kat mana tengok generic skill ni? Dia ada dekat CLO PO lah, yang tadi kat tengah course information tu. This is the component, the element of CO7 and so on ni. Ini akan cover on generic skills. So you need because this is we need to fulfill the engineering accreditation council. Kalau tak, nanti you tak boleh accredit course you. So that's why we need all of that lah. Okay, so kalau you tengok dekat sini so we divide into 2. One is the group marks and another one is individual marks. So this is really important. I will share to you in the e-learning after this. Okay, so for example, research background. Okay, of course, after this you will select. You need to select your teammate. Either you want to select by your own, or you leave it to me to I will rearrange the group. Okay, you let me know after this. Okay, and then for example, you have selected your own topic of the project. Of course, we need to discuss. If you don't have any idea, I have a lot. Not a lot. I have a few. I have a few areas which is currently I've been working with certain industry that we need a few creative design to solve the main their problem lah. I have a thing more than 2 Okay. Ada apa? Geran tak boleh bayar korang. Itu masalah dia. Okay. Alright. So for example bila you buat research background, katakanlah you have in your group 4 to 5 student. So you must, every single student, bila you buat your own research background, you kena collect, you kena record lah. Kat mana you ambil, where is your reference, where do you refer this, okay, you kena record. So nanti bila you buat report ni, this is by, contohnya, okay, by Siti, this is by Sharwi, this is by Muhaimin, this is by Mirza. All this name is required to state there, so that I will give the mark based on this. Okay, and then problem statement is a group, because you need to have only one problem statement based on the research background by every single person. Alright, and then you need to review of existing product or pattern related to the project provided or project that you have selected lah. Okay, so it's 5 marks. Okay, so this is a critical area. Sometimes student miss on this particular part. And then lastly, on the PDS, product design specification, it is a group, because PDS, you cannot have different PDS. Okay, one group, one PDS, because PDS is what? Agreement between you and other colleagues or other member. So we need have one PDS only for per group. Alright, and then we have to phase 2, we have concept generation, which is you will translate design problem into multiple solution in terms of sketching lah. You dah buat macam sebelum ni, is a 15 mark, it is an individual marks. Okay, so like previously, same. And then phase 3, we will have the design selection. For example, if you have 5 member in your group, we will have 5 sketching. Okay, then we need to select from that one. You need to do the scoring based on the evaluation that you have learned in I2D session. So it is a group. Okay, 5 mark only. Okay, and then phase 4, this is the most critical part, the analysis part. We call as the design embodiment. You have the initial design embodiment. What did we mean by design embodiment? Is that final concept is still a sketching. So you need to translate the sketching into the something that can be measured, something that can be provide a meaningful information, dimension, volume, materials. So that is what we call as design embodiment. How to assemble, how many parts, because in sketching you cannot see how many parts that will involve. So in design embodiment we can see how many parts. Okay, so you have material selection, bill of materials, how many quantity you required, what is the sizing and so on. And then we will be looking at on the design efficiency. Is that your whatever, for example, you come up with 100 parts, is that really efficient? Is that all required? Then we have the table so that you can do some process planning. Is all these component needed? Can we reduce a little bit? Which part can be simplified and so on? So that relies on the design efficiency. And then we have the design for functional analysis, design for manufacturing and assembly. So that is DFMA, design for manufacturing and assembly. You will looking at, is that possible? Because sometimes you do your part is very nicely look, but some it cannot be manufactured. Okay, so you need to know which types of manufacturing or fabrication techniques that you want to use to fabricate the component. All right, and then we will have the FMEA. FMEA stand for what? Failure modes engineering analysis. Okay, you have a table, then you need to identify the potential problem and what is the solution to the potential problem based on component that you have come out. And then engineering analysis. This is where all the analysis related to the project need to be analyzed. If, for example, the basic things for example, you have a shaft and so on, of course, you need to have the free body diagram. And then if involved the bearing, gears, sprocket, belting and so on, you need to use the component design analysis. And then if you deal with the fluid, for example, or if you fill with the oil, the palm oil punya case, then you need to embed with the fluid. If there is about the thermal punya system, then you kena masukkan thermodynamic. Okay, if you do the control system, then you need to include as well the Arduino system and so on lah. So that is engineering analysis. Alright, so that is why the mark is 15. It's huge. Alright, And then the phase 5 is basically visual prototyping, construct and test working model, 5% engineering drawing, 5%, and then construct and test working model, which is proof of function, is 10 marks. Okay, this is group. Okay, generate documentation ni 5 is you need to apa nama, bila you rearrange a group nanti, you kena tengok what is the individual punya task lah, jangan semua buat seorang buat semua. Okay, lastly generate skills, communication, individu, communication, poster, group, this is all group, logbook also group. So do you need to have logbook So like I2D previously, I think if I still remember, I asked you to record in a PowerPoint. Every single discussion you record in PowerPoint. So that is easy for me to trace. Okay, your your assumption and so on. Or if you have another thing to record, that is possible as well lah. So entrepreneurship, okay, we need to looking at, is there possible to sell that product? Okay, team working is 3 marks. And lastly, sustainability, are this related to sustainable goals or not? Okay, alright, so that is cost you 50-50, individual and group marks. Okay, so how do we evaluate? For example, research background, how can we determine 3, 2.5, 2.8, 2.72 or 1.5? It depends on this rubric. Okay, so these rubrics will tell us something. Okay, alright, so critical review, for example, okay, research background is 3, and we put a scale up to 10. Okay, so 8 to 10 marks, normally I will give 10 straightforward if I feel that you have made a critical review. So what is critical review? So basically right now also you are I think a lot of you takes final year project, you will have the literature review. Okay, here also mention critical review of literatures, means that once you get information from any sources, books, journal, scientific articles, website, and so on lah, all of the resources, don't just copy and refine the word. That one is for the sake of plagiarism. That one can be passed. Okay, so what I want is that review. Okay, for example, Manchester United kalah dengan apa? Leicester City. So what is your review? What is your comment? Don't tell me what is the manager doing this. No, I know on that particular part. What is your comment? What is your review? So that is the thing that we want to hear. Okay, that the thing you want to explore. I found that this product has flaws in terms of this. This is where the things that can be improved further by implying blah 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 blah. So those kind of review that we are needed. Okay, so that is for example lah. Same goes to another thing. I will provide to you as well this rubric for your references. Okay, is there any question on this particular part? No okay je.
I think no, Doktor. Okay je.
Alright, okay, thank you. Apa lagi nak bintang ni? Nak masuk first lecture ke? Betul tak ada soalan ni? Oh, bagus kau ni. Alright, okay. So because pukul 12 nanti saya ada meeting dengan Sam Dabi. Okay. Sam Dabi to be looking at on the project lah that Sam Dabi looking at, and I think some of that particular project I will make of our class system design project lah. Okay. So I think is this better right now? I can start my lecture. I believe it will more than half an hour. Okay, but somehow what I want you to do right now, okay, do you want me to arrange a group for you or you want to find by your own self? Okay,
Our own.
alright. Okay, if you want to find by your own, that is easiest to me. Sekejap saya tengok lecture notes ni panjang. Kalau tak panjang saya nak start sekejap. Wait. Okay. You find lepas ni dekat dalam kita in our WhatsApp group. Okay, you need to write your your group lah, your teammate. 4 or 5. Supposed to be we'll have around 7 or 6 group lah kot. Apa tadi? Lecture note. Is there any question before I start lecture? My lecture note, my first lecture. Oh, Aiman Jaafar dah left lah. Is there any question? Wah, panjang juga. Okay lah, bolehlah masuk sikit. Is there any question? Ada? Tak ada? Kriteria. Contoh kriteria apa Tanya, kita ada berapa orang perempuan ni? Saya tak. Kita ada berapa orang perempuan ni? Tanya yang perempuan lah. Do you prefer macam mana? Okay je ke? Ya tak kisah sangat. Okay, tak apalah. You find, you try find out dulu your group. And then kalau siapa yang tak ada group nanti, kita akan discuss lah. Saya try susun lah macam mana. Okay?
Okay doktor.
Alright. Okay.
No hal.
So for the first start ni, I think sempat kot saya nak lajukan ke macam malah nak lajukan pula. Okay, tak apalah, kita start dengan first lecture tu. So that in coming Thursday ni kita discuss sikit je lah berkenaan dengan projek. Okay, let me share window. Okay. Alright. Benda ni, help me protect. Okay, good. Alright, so we'll start with the, again, this is my name. Just a bit introduction again lah. Apa-apa kalau you have anything to apa nama, for example lah, if you need to, based on the project, for example, if you want to take the project from Samdabi, and then you feel that you want to make a visit to the Samdabi punya plantation, and then I think just use proper email lah. You email by me and then I can forward to the R&D department of Samdabi. And also I have also right now project is still in discussion with the Pacific Oils. Sendirian Berhad also doing on the palm oil. They have on the oil filling. Maksudnya dia ada from the tanker after the refinery process and so on, minyak masak tu, and then they already make apa nama ni, processing line, oil filling mechanism for 1 liter and above, up to 20 liter bottle, 20 liter bottle lah. So right now they want to basically looking at on the 500 milliliter. The concept is different because the 500 milliliter, basically the bottle is a cylinder, it's not a cylinder, rectangle, but somehow dia punya apa, ketinggian tu menyebabkan bila kita tuang minyak tu, once kita make a oil filling, sometimes dia boleh flip. So that is the main reason we need to design the whole machine lah, or the production machine. So that also the part. Okay, for example lah, that one you can discuss later on. Okay, so and then this is my website, you can have a visit. Atau ada apa tu tengok lah. Alright, okay. Alright, so basically mechanical engineering design in a broad perspective. I think this is, siapa yang ambil kelas komponen pun saya sebut benda yang sama. Because you kena nampak what is the difference between you and pure science. Okay, the first column here, tak tahu warna apa ni. The essence of engineering is the utilization of the resources and laws of nature to benefit humanity. This is the essence of engineering. Nampak tak betapa sucinya hasrat menjadi seorang engineer. Okay, to benefit humanity. Tapi korang kelas datang lambat, masuk kelas tak dengar lecture, assignment tak hantar.
Sorry doktor.
Nampak kan? So it's about to benefit the humanity. Nampak that is the essence of becoming an engineer. Alright, so basically kat dalam thermodynamics ke, fluid ke, solid mechanics, you dah belajar pasal all the formulation, laws of nature kan. Macam mana, siapa, uncle apa nama tu? Uncle Einstein kan. Uncle Einstein duduk bawah pokok, tiba apple jatuh, dapat idea kan. Macam mana uncle dapat idea pun kita tak tahu. Tapi that is laws of nature. So nak kata macam itulah. So kita akan guna to benefit for humanity. Same goes to engineering is an applied science. kita basically all the sciences part, all the understanding theoretical is from the science. People who do, for example like me, contohlah saya buat PhD, philosophy of degree of philosophy kan. So kita sampai up to the level basically scientist punya level lah. So kita akan research on certain part that provide science to the new knowledge. So that is a science, but when kita nak utilize the equation or formulation to based on the certain application, that we need an engineer. Okay, so basically engineering is an applied science in the sense that it is concerned with understanding scientific principles and applying them to achieve designated goal. Same goes to macam kita ada project. What is the purpose of the project? Kita panggil macam capstone project. You akan tie up all everything that you have learned previously 3 years ago. Okay, so you akan type all the information in this class, supposed to be lah. Okay, so mechanical engineering design, ni baru kita masuk. Mechanical engineering design is a major segment of engineering. You pergi kat mana-mana pun, you will apply this. You go pada industri, kalau you masuk dekat bahagian R&D, you will deal a lot of problems. So that is where mechanical engineering design comes in. Okay, it's a major segment of engineering. It deals with the conception. You kena tengok secara konsep, what is the main problem, so what is the solution, how do you want to design, what is your planning to solve that particular part. Okay, what is the development required. After you develop, sometimes you need to have a refinement. You kena tengok balik, is that okay this product, once you run, oh it's not okay, then you need to do back again. So that is refinement process. And all the application of machines and mechanical apparatus of all kind. So this is the idea of mechanical engineering design. Okay, so 3 level of design. So mainly the first one, the minimum one, or we call as the lowest one, the lowest level. This is the concept of introduction to design only, which is adaptive design, which means it involve a minor modification in the existing design only. Katakanlah contohnya macam nak buat kerusi, kerusi sekarang orang minat gaming punya kerusi, and then you nak buat some modification. That particular part can be lah untuk introduction to design, but some of that is the minimum level, adaptive design. The second level is that develop design, which is you refer to certain product. You take that particular product as your basis, as a reference, so that you can start. Sometimes we also don't know where we want to start. So you, macam biasa lah, macam assignment ke, project apa, eksperimen ke, we don't know how to start. So the easiest way to start is that looking at on the others. Boleh tak aku punya copy kau punya, nanti aku edit. This is the trouble that you have made previously lah. Okay, so but somehow it's a good thing. The process itself, you need to be looking at something to start off. Okay, so the entire concept or the theme is new and developed to produce a better product. So that is the developed one. So make a thing as a reference, but from that reference, you turn up into something better. Okay, in terms of design, in terms of development, the way it operated and so on. Okay, and lastly, the new design, new invention. A component or product is made from scratch. Okay, the designer must have complete knowledge of designing. This is one of the most complicated part. Alright, so sometimes you need to, your idea is really important. Macam saya cakap masa sampai kelas 1 ni dulu, I really appreciate cerita seperti mana Big Hero 6. Even though macam dia, alah doktor, tengok cerita Big Hero 6, kamu lah doktor. Sebab ada anak-anak kena tengok cerita tu. Tapi sama it is inspired in terms of few ways. And even though up till now, there is no such a product, okay, that use apa dia panggil tu? Brain punya sensor untuk control a certain what we want. So basically that is the main idea. Sama juga macam cerita Doraemon. Kalau you tengok for the sake masa you during your kids time lah, you tengok Doraemon just for leisure. Tapi sekarang you become manager, you tengok Doraemon how they portray this kind of technology. Sama juga siapa yang tengok cerita Dragon Ball, macam mana Bulma tu she can design a capsule. A big house can be capsulated in that particular capsule. How can that big kita deal a lot with density, materialnya ada density. How can it be shrinkage to that level? Downscale and upscale. So that is basically the prediction of the future. So that the way how you looking at on the story. Kalau you tengok One Piece for example, I don't know how to relate with the engineering part lah. Okay, right? Okay, proceed. For example, okay, how to evaluate this design? Okay. Kenapa ada holder kat sini? Function terus. What is the use for apa? Tujuan apa?
I think to carry that object maybe.
Ya, dia guna untuk tolak kan. Tapi
Ya.
kadang-kadang sometimes kita guna untuk lifting. Kita guna untuk angkat. Seperti kata kita guna kalau kita guna untuk angkat, which is this is not suitable lah. Alright. So that is the valuation that can we be made because you have nampak ada two handle here and also here. But somehow this is using for different purpose. Alright. Apa masalah dengan this apa nama ni cooker? Cooker kita panggil. Stove. Ha? Hulu tangan terbakar. Okay. So kalau you tengok kat sini everything all in place. Okay, semuanya nicely tersusun. But somehow once you buka dia punya apa nama tu, dia punya button tu, tangan je akan terbakar. So that is very bad design lah. Walaupun kita kata nampak it look okay. The second thing is that you might consider because of maybe you punya size of dia susun terlalu rapat dia punya stove tu. Okay. Same goes to this is one yang kita kata boleh lebih baik lah. Okay, yang ni tak apa saya skipkan dulu. Okay, what about this?
Oh. Massive traffic light design.
Massive traffic light design. Dia bagi kesan apa?
Confusion.
Yeah, yes, confused. Kalau you duduk kat sini, you tak tahu nak pergi mana. Mungkin itu tengah apa, leka ke, and then you cannot determine which way lah. Same goes to yang bawah ni Jadi sometimes dia nak sebelah kanan ni boleh masuk ke tak boleh masuk. So it give different apa nama ni interpretation on that particular design. So that is where bila you buat sketching sama lah. Dia nak emphasize ni, bila you buat sketching later on sama lah. So it must be self-explanatory. Bila tengok tu kita boleh faham. You tunjuk kat you punya kelip pun tak boleh faham, then that is trouble lah. Okay. Same goes to this. How the importance of fundamental knowledge. Okay, macam mana kita design, apa nama kita kata self-help design. Suppose macam kita buat tengok gunting. Scissors is a very basic design. What is the science behind that? Tu kita tanya what is the principle use. Kalau kita tengok dekat sini, all the forces come from where? From the
hand.
From our four fingers. Four finger bukan kedai makan from our fingers. Yang our thumbs ni basically just for support. This is where our fulcrum will help, and then the main cutting is from the from our fingers. So this is what we call as self-help design. So there are a lot, 1,000 of design. Sometimes I also maybe once you design a new things, and sometimes I also learn from you, because maybe my experience and my knowledge is during my time. So now it's a different time, different technology. Based on your research background, we will find a new thing. Okay. This is next quotation lah. Ni sedikit sesi tazkirah. Alright. So next quotation, genius is 1% inspiration and 99% perspiration. From Thomas Edison. Dia nak cakap apa sebenarnya? Apa yang dia nak cakap? Hard work. Lagi? Cik Siti dengan Zuki jawab ni. Yang lain tak nak jawab ke? Muhammad. Apa Muhammad?
Ya, saya doktor.
Apa Pak Cik Thomas Edison ni nak bagi tahu?
1% inspiration and 99% is perspiration. Sekejap doktor.
Jangan Google pula dia orang.
Doktor boleh baca fikiran saya ni.
Tak ada, kau bagi tahu je apa yang terlintas. Apa?
Oh, genius is 1% inspiration. Maybe dia punya inspirasi tu datang daripada sikit je lah inspirasi tu datang. Selebihnya 99% tu mungkin daripada perspiration bacaan ni ke apa?
Apa Siti perspiration?
Action.
Action. Bagi tahu. Okay. Saya nak cakap bahawa idea is really important. Penting tak ada idea? Penting. Tapi kalau you tak boleh bagi effort, is useless. Saya berfikir untuk jadi seorang engineer yang sangat hebat. Tapi you malas datang kelas. You tak nak score subjek you. So that is your problem. So that's why kita kata effort is really important. In design class, your effort, your commitment will be counted. Okay. Saya akan tengok on that particular part. And I really appreciate, once again I highlighted lah. If you not to be forgotten as soon as you dead or rotten, either write things worth reading or do things worth the writing. Ni from Pakcik Benjamin Franklin Okay. Alexander Graham Bell. Tak apalah ni, saya lajukan sikit. Masa nak habis. Okay, salah satu contoh Leonardo da Vinci. Okay, so he is a scientist, inventor and also artist. Scientist in what way? He himself did operation on human body to study the mechanical of human muscle and bone. This is my PhD all about. I'm looking at on the biomechanics. If you go to my website, kalau you tengok bahagian students tu, there are a lot of my final year project student. You akan nampak lah. Dekat dalam ni pun ada saya seorang punya student ni, FYP. Okay, this study contributes a lot of design of machine after his death. So kita nampak dia punya contribution. Same goes to inventor. Apa yang dia buat lah, Archimedes screw used to lift water. And artist in terms of what way, skill at creating the illusion of depth and distance on flat walls and canvases. Tak apa ni, cepat kan? Okay, pernah tengok video ni? Okay, saya bagi, nanti saya akan share link dekat WhatsApp. Saya minta korang tengok. Ke nak tengok sekarang? Ada masa kan? 2-3 minit je. Sekejap. Stop presenting dulu. It's a really interesting. Nanti kita akan buat activity Kena buat hari Senin ni Tak apa, saya bagi tengok dulu lah. Sekejap. Kejap Alright. Farid's not that. Iklan lah pula. Aduh. Alright. Tap. Share with tab audio.
Easy. But Grammarly can help. This sentence is grammatically correct.
Cranes use mechanical advantage to lift heavy objects. Their crates.
Dengar audio tak? Dengar kan?
Dengar.
Okay.
Very hard to comprehend how strong it really is. For example, there is over 30 kilograms of air stacked above this Rubik's Cube, exerting nearly 300 newtons of force on each of its faces. One of the easiest ways to experience the strength of the atmosphere is by using a syringe. And by pushing the piston all the way to the end, squeezing all the air out, and sealing off the end, we can pull the piston back and create a vacuum, essentially fighting the atmospheric pressure. Now, I've previously built a car that's powered by this atmospheric springing force, and this car translated this large amount of force over a short distance to a much smaller force over a longer distance. So even though the piston is only pulled back about 13 centimeters, the car could travel a total distance of 190 meters. Now, I also know that the pistons of these syringes want to contract very quickly, as I've used this to build syringe rockets in the past. So how about we harness this rapid contraction of the piston into a small car and build a vacuum-powered dragster? This video is sponsored by KiwiCo. More about them later. There are two important dimensions to this syringe that will determine the design of the dragster. The first is the diameter of the piston, as this is what the atmosphere will be pushing against. The larger the diameter means the more piston area. Therefore, the larger the force produced by the atmospheric pressure. The second important dimension is the syringe length, as this determines how far the car will travel. If I were to connect this piston directly to the rear wheels, there will be a huge amount of torque for a very short distance, assuming the wheels don't just spin out from lack of grip. So we need to convert some of this torque into increasing the range, using the mechanical advantage of a belt and pulley system. Starting with a thin axle attached to a large pulley, the forward force of the piston is transferred to a rotational torque at the belt. This then drives a much smaller pulley which is integrated into the rear axle, resulting in a pulley ratio of 1:3. So every time the large pulley rotates once, the rear axle will rotate 3 times, but with less torque. Taking the diameter of the initial shaft and the rear wheels into consideration, the overall ratio of piston travel distance to theoretical car travel distance is 1:26, meaning for every centimetre that the piston moves forwards, the car should move forwards 26 centimetres. With a pair of radio controlled car wheels attached, the ratio of wheel rotations to piston travel is a little clearer. I then added some front wheels and a release lever, which locks onto the rear axle, which when pressed down lets the rear wheels spin and the dragster accelerate. Watching the piston slowly creep forwards as the pulley rotates to drive the rear wheels at a rapid pace is oddly satisfying in slow motion. All it needs now is a rear wing to complete the dragster look. But there's one thing missing. How can it be called a dragster without performing a burnout, even with wet tyres? I think it needs more power. So I built a version 2. This car has 2 syringes, which produce a forward force of 80 newtons each, which is equivalent to suspending a 16 kilogram weight from the small 3D printed axle, producing 0.76 newton meters of torque, which is transferred via a 1:5 belt ratio to produce 0.15 newton meters of torque at the rear wheels, which is a little too much for this tiny car, even with some assisted tyre warming. With a lack of grip comes instability, as well as wasted energy, so it's difficult to set any record-breaking times. However, I still find it fascinating that the weight of the air above us can be converted into usable forward motion by combining a syringe with a belt and pulley system. Whilst we're on the topic of mechanical advantage, I have this crate from Kiwi.
Okay, dah kita tunjuk pasal ni dah produk dia. Alright, okay, so that is really interesting. Tom Stanton basically dia banyak buat DIY, so you can go to the channel lah. Alright, so later on kita akan discuss berkenaan dengan that particular video, okay, on coming this Thursday. And then the thing that you need to do right now, you need to form your own group, okay, then you let in the group, in our WhatsApp group, who is your team member. And then on this coming Thursday, we will have at 2 p.m. and I will let you know lah what is the time. Okay, so I think that's all for today. Is that okay for all you guys?
Okay, Doktor.
Alright.
Okay, Doktor.
Mantap.
Okay, so with that, I would like to say, sebelum tu, lupa attendance. Rugi lah tadi.
Doctor, there will be class on this Thursday?
Yeah,
Because so
hopefully,
far
hopefully.
I heard there will be public holiday. I'm not sure about that.
Holiday?
Yeah, public holiday or something.
Kenapa?
Maybe you can cross-check with it.
No, tomorrow is holiday.
Tomorrow is Maulid Rasul.
Tomorrow is holiday. Not this Thursday. I think you heard Tuesday. Oh, the Tuesday. Okay,
maybe.
Okay, so there is a attendance link. Please fill in by now. Alright, so with that, I need to go to another meeting with Sam Dabi. Okay, thank you guys. Assalamualaikum warahmatullahi wabarakatuh and bye.
Waalaikumsalam, Doctor.
Bye, Doktor.
Doktor.
Bye.